is my first attempt at this. Hopefully, it's not going to end up sucking too bad. Um, so, day 13, if you recall, was a really long time ago at this point, but we started to do a lot with unit conversions, and particularly between acceleration units of miles per hour per second to meters per second, or otherwise known as meters per second squared. Um, Anywho, units. Usually best to convert to metric before you try the problem. Do you have to? No. Do I think it's the easiest way? Yes. So, a couple of things, units you kind of need to know. There are 1,609 meters in a mile, 3,600 seconds in an hour. Hopefully, you know that by now. 5,280 feet in a mile, 3.28 feet in a meter, or 0.305 meters in a foot. Interestingly enough, there are 10 pi megaseconds roughly in a year, which is kind of a fun little conversion that I know of. 1.61 kilometers in a mile, and then I have a little plaque down there for smoot. It's not an official unit, but apparently it got popular enough. It's based off of a physicist at MIT. They actually measured the length of a bridge in his height, and it kind of stuck. It's roughly 1.7 meters. So there are a lot of different units out there is basically the gist of what I'm trying to say. Some equations we know at this point. Delta x is equal to your average velocity times time. Or, since we know that average is the initial plus the final divided by 2, you can express it as the delta x is equal to Vf plus Vi over 2 times delta t. This right here is your definition of acceleration. Vf is equal to Vi plus A delta t, which is the same as saying Vf minus Vi divided by delta t is equal to A. So it's just the acceleration equation, or the definition acceleration, sorry. And finally, probably my favorite is delta x is equal to Vi delta t plus 1 half A delta t squared. Why that one? Well, because if you have a constant velocity, that means your acceleration is 0, and so it's just rate times time equals distance. So this works in all fashions, whether you have an acceleration or you don't. So, anywho, doing a practice problem with some unit conversions this time. We'll see how this works out. We have a pigeon dropping. It's shot at 5 miles an hour directly down from a height of 6 meters and strikes a kid on the head 1 meter above the ground. We want to figure out the initial velocity in meters a second, hence the whole convert to meters a second first usually helps. We also need to find the time it takes for the dropping to impact the child and the velocity upon impact. So first things first is I'm going to try to convert that 5 miles an hour to meters a second. So I take 5 miles over 1 hour times. I know that there are 1,609 meters in a mile, and I know that for every 1 hour there are 3,600 seconds. Whoopsie, that is a 6. I need a 0. There we go. Alright. So hours, as you notice, cancels out. And miles cancels out. That leaves you with meters over a second. And I have a calculator here. So 5 times 1609 divided by 3,600 is going to be 2.23 meters a second. So let me write that here, 2.23 meters a second. So that's my initial velocity. Now, I'm going to erase this real fast here. Now, we know that the initial velocity is 2.23 meters a second, but I did say that it's going directly down. So your initial velocity is actually going to be a negative 2.23 meters a second. The speed is 2.23 meters a second, but the velocity is negative since it's going downwards. Okay. Couple other things. So we know our pigeon is way up here. There's my bird. And it's actually happened to me, this whole scenario. I'd taken off my football helmet. It was in middle school football practice. And a pigeon just crapped directly in my eye, of all things. That's kind of where I got the idea of the problem. Strange. I was not 1 meter tall, by the way, but we did this to make things easy. Here's the child. He does not like it because I didn't. Ow. Okay, I didn't say ow. It's more gross, but you get the picture. All right, so we know that this is 6 and this is 1, so the actual displacement is going to be 5. Reason why I drew this is because your x is going to be a negative 5 meters because it's only going to travel 5 meters. And then you should know at this point or rather remember, because it's been a few weeks, the acceleration due to gravity is a negative 9.8 meters per second squared. So we know 3 things. We want to know the time it takes for the dropping to impact the child. As I said, that one of my favorite equations is x equals vi delta t plus 1/2 a delta t squared. We know x is negative 5 meters. We know vi is negative 2.23 meters a second. Delta t minus 1/2, I just brought it out front, of 9.8 meters a second squared. Delta t, oh, ran out of room. Delta t squared. It's cut me off over here. All right, I'm going to drop the units and move my 5 over, because I'll show you why. That gives me, and I'm going to rearrange it as well. 0 is equal to negative 4.9 t squared minus 2.23 t plus 5. This should seem familiar to you because this is the quadratic formula. 0 is equal to ax squared plus, that's not a really good square by the way, ax squared plus bx plus c. If you recall, the quadratic formula over here is, oops, let me right here. Oh, I have to go all the way back here. The quadratic formula, let's see here, I can scroll down. Can I? No, I can't. Fun. Alright, we'll do it down here. Alright, it should be y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, coming back up here, I'm going to erase my picture. So that'll be a 2.23. Let's see if I can fit it in here. 2.23 plus or minus. Ooh, it's going to be a tough one. Not going to be able to fit it there, am I? No, I am not. Let's do it right here. 2.23 plus or minus the square root of 2.2, we'll just say 2.2s for now, squared minus 4. A is negative 4.9 and C is 5 all over 2A. So that'll be 2 times a negative 4.9. Oopsie, that didn't look too good, did it? Negative 4.9. There we are. Okay. Now that we have that, I'm going to erase. You can always, I guess, rewind. Rewind, is that the word anymore? Go back, I guess, and see what I did earlier. When you solve this, you're going to get 2 roots. One might be negative. You can't have negative time, at least not in this class. You could, or negative duration, I'm sorry, at least not in this class. And so, let me calculate what that's going to be. I have a handy dandy equation solver that's going to solve this a lot faster, which is good because, well, just as good. That'll be 5 meters, enter, solve. You should end up getting 2 roots when you do this. I'll write them both down for you. You should get that, oopsie. Let's finish erasing that. There you go. Delta t is equal to, and you should get 0.81 seconds, and then you should also get negative 1.2, we'll just call it negative 1.3. That one can't be used. We need to use this one. So it takes about 0.81 seconds for it to hit the ground. Now we also want to know the velocity upon impact. Well, we know that Vf is equal to Vi plus A delta T. And then, well, okay, I'm looking for velocity, Vf. My initial velocity was a negative 2.23 meters a second plus a negative 9.8 meters a second squared. We want to know upon impact, and so it traveled, or rather it took 0.81 seconds to hit the ground. And I'm totally running out of room here. It's going to take me a while to get used to. There, close enough. Plugging that in my calculator. Let's see here. Gotta talk loud so you can hear me because my microphone's not all that good. Negative 10.2. So your final velocity is going to be a negative. Why'd I write 2? Don't know. I said 10.2 meters a second. So that is your final speed. And that concludes, I guess, my first test run doing this. If you have any questions, please email me. I'm probably going to go over that later. But yeah, this is my first test run.